Welcome to Math is Beautiful. In this video, we explore one beautiful concept, the Pythagorean Theorem. First, we will prove why it is true, and then we will use it to solve a problem. Prove the Pythagorean Theorem. Everyone can recite it. Today we earn it with nothing but similar triangles. Here is our right-angled triangle. The right angle at B, legs IB and BC, hypotenuse IC. First, the claim in full. The right angle sits at B, so the side opposite it, IC, is the hypotenuse, the longest side. The theorem says, IB squared plus BC squared equals IC squared. The whole proof hangs on one construction. From B, drop a perpendicular onto the hypotenuse, landing at D. It splits our triangle into two smaller ones, and both, miraculously, have the same shape as the original. Why the same shape? Remember the rule for similarity. If two triangles agree on two angles, they agree on all three and are just scaled copies of each other, similar. We only need to find two matching angles. Compare the small right-hand triangle BDC with the whole triangle IBC. Each has a right angle at D and at B, and they share the angle at C. Two matches, similar. Similar triangles keep their ratios. Short leg over hypotenuse in the small one, CD over BC. The matching pair in the big one, BC over IC. Cross multiply, BC squared equals IC times CD. Keep it on the side. Now run the mirror argument on the left-hand triangle IDB, a right angle at D and the angle at I shared with the big triangle. Similar again, ratios again, and this time, IB squared equals IC times ID. Park this one too. Now add the two parked results. IC is a common factor, so the sum is IC times the bracket ID plus CD. And look at the figure. D sits on the hypotenuse itself, so the two pieces ID and CD lay end to end and together make the whole of IC. Substitute and the bracket becomes IC. IC times IC, IC squared. The claim is proved. The two squares on the legs exactly fill the square on the hypotenuse. Now let's look at an application of this concept. The two shorter sides of a right triangle measure 6 centimeters and 8 centimeters. Find the length of the hypotenuse. Here is the triangle. The two legs are 6 and 8 centimeters, and we need the side opposite the right angle. First, identify the players. The right angle is at B, so the unknown side X opposite it is the hypotenuse. 6 and 8 are the legs. The parked theorem says, hypotenuse squared equals the sum of the two leg squares. X squared equals 6 squared plus 8 squared. 6 squared is 36, 8 squared is 64. Their sum, 100. The side we want is the square root, 10 centimeters. And a quiet check, 6, 8, 10 is just the famous 3, 4, 5 triangle doubled. So that is the Pythagorean theorem, proved with similar triangles and put to work on a real triangle. Thank you for watching. If you found this video helpful, do like it, subscribe to Math is Beautiful, and share it with your friends.